Hello all, welcome to part 4 of the Buffer Overflow Primer video series. In this video, we will look at how to write more complicated shellcode than the simple exit syscall shellcode which we had dealt with in the last couple of videos. So in order to do something useful with the shellcode, it has to be more powerful and probably encapsulate more syscalls. So this video will be dedicated on how to write shellcode for spawning a bash shell. So let's go to our terminal. Now the first thing one has to realize is that in order to go ahead and create a new process, we can either use the fork syscall or the execve set of syscalls, depending on exactly how we want the new process to behave with respect to the parent process. In this example, we will use the execve syscall. So let's do a man. So execve is going to execute a new program and go ahead and overlay the parent program's memory with this new program. So what is the input execve takes in? The first is a pointer to the file name of the program to be executed. The second is actually an array of argument strings which need to be passed to the program. The third is an array of argument strings for the environment. Now the important part to note here is that both argv and argp need to be terminated by a null pointer. So with this basics in mind, let's look at how a program which can spawn a bash shell would look like. So here is the C code, and if you notice, what we've done is we've declared an argument array, right, where the first member is nothing but pointing to the bin/bash string, and the second member is a null. And then we go ahead and call execve with passing the pointer to the bin/bash string. Then we pass it the argument array, and in case of the environment, we go ahead and just leave it as null because there is nothing specific we want added to the environment. Now let's go back to the terminal and look at some C code. So this is the program. Let's compile it. And now let's run it. So if you notice, as soon as we ran it, a bash shell got invoked, right? So we can now do any of the bash things here and then simply exit once we are done, and we are back to our program. So very simple piece of code of how we can go ahead and invoke a bash shell using C program. Now let's try and understand how this program looks like in assembly. So let's load it up in GDB and let's disassemble the main function. Right? So this is how the main function is looking like. It does a host of activities before actually going ahead and calling execve. Now the point we need to understand is that in this case, the C library execve will be called, because of which all the input arguments to execve are going to be pushed onto the stack, right? So what we shall do is that in order to understand this program better, we will go ahead and trace through each one of these instructions to look at exactly what is happening before the execve call happens. So let's go ahead to our slideware. So we are going to trace the stack for the execve syscall. So as we know, the stack is laid out from high memory to low memory, and is basically right now we keep the stack boundary to be 4 bytes, right? That is where the preferred stack boundary is equal to 2 came in. Now let's look at the first instruction. the first instruction is to push EBP onto the stack. Okay, so the old value of EBP is on the stack and ESP has been updated. The next instruction is actually to move the current value of ESP into EBP, right? What that means is now EBP also points to the top of the stack. The next instruction is to subtract 8 from ESP. Now, if we look at it, the stack is laid from high memory to low memory, and hence if you subtract 8 bytes from ESP, then ESP is going to go down further in memory, right? So let's do the subtraction and let's leave these 2 8 bytes as is. So basically this is how space is allocated onto the stack, right? The next thing we are going to do is to move a specific address into the location pointed by EBP minus 8 bytes, right? So EBP is pointing here, minus 8 bytes would be the top of the stack currently, which is here. And what we are going to do is put this address inside this memory location, right? But however, what is this address? Let's go ahead and examine the memory here. So if you notice, this is nothing but the address of the bin/bash string, right? So this is actually a pointer to the bin/bash string. So when this instruction is executed, what we will have is that the pointer to bin/bash is what is occupying EBP minus 8 location, right? Now the next instruction is going to move the value 0 into EBP minus 4. EBP points here, EBP minus 4 begins here, which should mean this is the memory location we are talking about on the stack. And we are going to move a 0 here, and this is nothing but a null as represented in a C program, right? Let's go back to our instructions. The next thing which we do is go ahead and move the value which is there in EBP minus 8 memory location into the EDX register. So EBP minus 8 is nothing but this value, which is a pointer to /bin/bash. And now EDX contains this value, which is nothing but the pointer to bin/bash string. The next instruction is to push once again a 0 onto the stack. 0 is nothing but a null as described previously. Next instruction is to load the effective address of this specific location, which is EBP minus 8. Now EBP minus 8 is nothing but pointing to this specific location, right? And we are going to load the effective address of this into EAX, which means actually EAX is nothing but pointing to this specific memory location. Now we push the value of EX onto the stack, and then we push the value of EDX onto the stack. So let's push EX onto the stack. Let's push EDX onto the stack. And then we go ahead and call Execve, right? Before we do that, let's examine this a bit further. So EDX, as we noticed, is nothing but a pointer currently to bin/bash string, right? And EAX, that is doing nothing but pointing to the pointer to /bin/bash, right? So let's try and understand what happens when Execve is going to be called. Right, let's go back to our terminal to a man execve. Now, as we've seen in the assembly language primer video series, is that whenever you're passing arguments to a libc function, everything has to be on the stack, and the function is going to retrieve all of them from the stack. So the first thing to be retrieved is going to be the file name, a pointer to the file name, which is going to be executed. So if you notice, the top of the stack is nothing but a pointer to the file name bin/bash. This is what Execve would expect, Second argument is nothing but a pointer to an array of argument strings, right? So EAX is nothing but a pointer to an array of argument strings. The first is of course going to be pointing to the name of the file itself, bin/bash, and the second is nothing but a null pointer which says, okay, this is all, there are no arguments which need to be passed to bin/bash. So this is where EAX points to the array of arguments which consist of a pointer to bin/bash and a null. Then finally, the environment array pointer is nothing but the null which we have also placed on the stack. So very simply, these three are the arguments to Execve, right? Pointer to bin/bash, pointer to the arguments array, pointer to the environment array. And hence, when we run Execve, it calls Execve, it goes ahead, fetches this all from the stack, and then goes ahead and overlays the current process with the bash program. So a very simple video till now. Now what we'll do is, let's go ahead and try a simple assembly language program which will emulate exactly these following steps and invoke Execve. Okay. So we've written a very simple program, exec.s in assembly, in order to go ahead and see how we can emulate the Execve syscall in assembly. So we've defined a string called bash, which is null terminated. Then we have a null1 label, which is nothing but an integer of value 0. Then we have an address to bash label, once again an integer of value 0. And then we have null2, which is again an integer of value 0. Right? So how do we go about invoking the Execve syscall? Now if you remember, when you invoke the syscall, all the arguments need to be in the register, as opposed to when you invoke a libc call, in which case all the arguments need to be on the stack. So here we need to load all the arguments in the register. So the first is to load EAX with the syscall number for Execve, which is 11. The second, if we actually go back to our syscall definition, is going to be the first argument to Execve, which is nothing but a pointer to the file name. And if you notice, what we've done in the instruction before is loaded the pointer to the file name bin/bash into the address to bash memory location. And now what we do is load the memory location of the bin/bash string into the EBX register. Right, so this is argument number 1. The second argument is nothing but a pointer to an array of arguments, the first of which is the file name. So if you notice, address to bash is nothing but a pointer which goes ahead and points to the bash location, which basically is the bin/bash string, right? And the important thing to note here is that the next argument in the argument array is nothing but the null which we have defined in null1. So in memory, this is laid one after the other, and thus it looks as if this is nothing but an array of pointers, the first of which is pointing to the pointer to the bin/bash string. The second is nothing but a null pointer. So this is where argv is actually loaded. The third is environment pointers, and this is where this has to point to an array of pointers which have the environment details in them. However, because we need no changes to the environment right now, we'll just go ahead and load the address of null2 into the EDX register. Right? This is once again a null value. And then we go ahead and invoke the syscall interrupt. And then finally we have the exit routine. I think everybody is familiar. So once again, let's go through this. First, we go ahead, load the syscall number for Execve into EAX. Then we load the pointer to the bin/bash file name into the EBX register. Then we load the pointer to the array of arguments, the first of which is bin/bash and the second is a null. And finally, the third is actually loading the environment pointer array, which is nothing but a null, right? So then we go ahead and issue the syscall. So let's actually assemble this program. Let's link it. And let's run it. So if you notice, once again, we get the bash shell. Right? You can exit from this. So in this video, we saw how it is possible to go ahead, reverse engineer a given syscall using its C programming language equivalent, looking at the assembly language code for that executable, and then going ahead and mimicking the same behavior in assembly. So as we all know, now if we had to go ahead and look at the shellcode, all we need to do is go ahead and load this up in object dump. And this is where we get the equivalent shellcode for the entire process. So, however, the shellcode still is not in a form in which we can really inject that into a process vulnerable to a buffer overflow. In the next video, we will look at how we will modify this specific shellcode in order to make it compatible to injection into a process vulnerable to buffer overflow. Well, that's all for this video. I would really appreciate if you can leave your comment and feedback behind in the leave a comment section. Thank you.